Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 17 of 2015 JEE Advanced Physics paper. So let us start with question number 17. Students, let us solve question number 17 of 2015 JEE Advanced Physics paper. The question is, a ring of mass m and radius r, this is a ring of mass m and radius r, is rotating with angular speed omega. This is rotating with angular speed omega about a fixed vertical axis. This is the vertical axis. So the ring is rotating like that, passing through the center with 2 point masses, each of mass m by 8. So there are 2 point masses. As you can see, these are the 2 point masses at rest at O. At the center, these 2 point masses are at rest. These masses can move radially outwards. Radially outward direction is shown. Along two massless rods. These are the rods which are having negligible masses on the ring are shown in figure. At some instant the angular speed of the system is 8 by 9 omega at some instant, and one of the masses is at a distance of 3 by 5 from O. 3 by 5 it should be 3 by 5 r from O. It should be 3 by 5 r from O. At this instant, the distance of the other masses from O is, that means there is a ring here, and there is a rod. This is one, this is second rod, and there are two masses. One mass is here, another mass is suppose here. This distance from O is given as, this distance from O, suppose this is the first mass and this is the second mass. The distance of first mass, all these masses are having mass equals to m by 8, m1, and also mass m2 is m by 8. This one is at a distance of 3r by 5, 3r by 5, and this distance is to be found at this instant. So when this is rotating with omega, but at the time when after time passes, when this omega becomes 8 by 9 omega, that time these two masses starting from here, one is reaching to this place at a distance of 3r by from O, the other mass will reach some distance, suppose x. This is the distance x, and you have to find that distance. At this instant, the distance of the other mass from O, that means you have to find x here. This is the distance of the other mass from origin. So now this ring has mass m and radius r. Now, based on the principle of conservation of angular momentum, we have to apply conservation of principle of conservation of angular momentum, which says that in the absence of net external torque, the angular momentum of the system will remain conserved. So if this omega becomes 8 by 9, because when this starts rotating, this will move radially in this direction, and then because of that the omega will change. It is not this increase or decrease of omega is not because of the external torque, it is because of the internal torques of the system. So we will write that in the absence of if external torque is 0, net external torque is 0, the angular momentum of the system is constant. So the initial angular momentum must match with the final angular momentum of the system. The initial angular momentum is that these two masses are at rest. There are total 3 objects. These are the 2 point masses and one is ring. These two are at rest, so angular momentum of these two, when the omega, initial omega is in this case the starting with omega, and here it becomes 8 by 9 omega. So these are the two conditions. So initially these two are at rest, so only the ring is rotating and it is having pure rotation. So in case of pure rotation, the angular momentum of rotating ring will be I omega. I is mr square. Ring is having mass m and radius r, so it's omega. So its moment of inertia is mr square multiplied by omega, because omega is its initial angular velocity. That must match with the, now the objects are moving away from the origin. This we are finding with respect to the origin O. This is the initial angular momentum about O. This is the final angular momentum about O. So now when the objects are for the ring, it is mr square. For ring there is nothing going to change, mr square omega, and now this time omega is this 8 by 9 times omega plus the plus the angular momentum of these two masses. These two masses, if this is rotating, this will also rotate. So moment of inertia of this mass at the instant when the angular velocity becomes 8 by 9 omega, for the first mass it is at a distance 3r by 5 from the origin. So mr square for a particle, the formula for moment of inertia is mr square, but here r is this distance square is this 3r by 5 square. So it is mass of the particle, that is m over 8. mr square, r is 3r by 5. This is the distance mr square, and omega is 8 by 9 omega, plus the second mass having same mass, and at what distance is there we don't know, so it is x, suppose x square. This is the moment of inertia multiplied by the omega, that is 8 by 9 omega. Now solving this, m r square omega, m omega you can cancel from all, you can cancel m omega from both sides of the equations. M omega, m omega, m omega, m omega. Here it is r square, this implies r square is this 8 by 9 I can take common out. Here it will be r square, r square 8 by 9 common. I take 8 by 9 common, it is r square. Here it is 339 divided by 25, so it is 9 divided by 25 into 8, r square. So this is 3 3 is a 9, 25, 8 is there, 8 by 9, 8 by 9 is taken out, so it is not considered, plus this is x square divided by 8. Okay, now from here this is 25, 8, 200, so this is 200 r square. I'll write this as that implies so I'll write this implies that r square is 8 over 9. This is 200 r square plus 9 r square divided by 200 plus x square over 8. Just I have done what? The LCM of these two terms. This is 200, so this will be 200 r square plus 9 r square divided by 200 plus x square by 8. Okay. Now this is I can take this to that side. This is 9 over 8 r square, and this will become 209 r square divided by 200 plus this 8 by 9 will multiply with this, so it will become x square by 9, because okay, this is actually taken out, so it is only x square by 8, because this is taken, this is multiplied with this is taken to this side, so this will be remain as it is, x square by 8. Now this also is taken to the other side of the equation to get x square by 8, so x square over 8 equals to, if we solve this, then this is 9 over 8 r square minus 209 divided by r 200 into r square. If I cut this 8, this will be 25, so that means it is x square equals to 9 r square minus 209 divided by 25 r square. So this implies that x square is 25 9 ja, it is 225. So 225 r square minus 209 r square divided by 25. If we solve this again, it will become I'm just copying it out. X square is 225 r square minus 209 r square, that I have calculated just now. This is if I take 200 225 9 16, so it is 16 r square. Okay, so this will become 16 r square. You can see here this 225 209 to 220 cancel, 25 minus 9, it is 16 r square divided by 25, so 16 r square divided by 25. So x will become, taking the square root of this, it is 4r divided by 5. So this means that if I consider the other particle, which is here at a distance x from O, at this instant the distance of the other mass from O, which is x, and is found to be and so x is 4r by 5, and so this is the answer of x, which is 4r by 5, it is 4 by 5r. So this is the answer to this question. So by the time when the ring will have this omega 8 by 9 times the angular velocity, then at that time this will be the answer. The other particle will be at a distance of 4r by 5 from the origin. It is one point you have to note, it is that the when this starts moving, the I will increase. And basically the concept is that we can see that it is basically I omega is constant. So that means omega is inversely proportional to I. That means when the masses start contributing towards the moment of inertia, as it starts moving away in this direction, they will contribute to moment of inertia. The moment of inertia of the system will increase. Because this increases, the omega will decrease. As you can see that it is omega, which is 1 omega, and 8 by 9, which is less than 1. So the omega is actually decreasing because the masses are moving away from this point. So because these masses are moving away, the I will increase and omega will decrease. So this is all happening in the case that there is no external torque acting on it. The system's angular velocity is decreasing only because of the movement of the particles away from the origin. Okay, so the more and more they will move away from the origin, the omega will keep on decreasing. So this is the one instant when the omega is this, that where the objects are asked. So that is it is not that both are having same masses, so both will be at the same distance. So many students might think that this will be 3r by 5, which is this one, but this is not right, that they will have different positions from origin. So answer to this question is 4 by 5 into r. Okay, thank you.